Okay, Assalamualaikum. Today we're going to continue our session. It's tutorial 6, and this will be the last tutorial for us. And next week we're going to have the case study 1 and 2. Okay, today we're going to do a two-dimensional instationary morphology model. Okay, we will see beach evolution due to a presence of parallel structures, or we call breakwaters. And we can see after the simulation, there will be a formation of tombolo and can be seen. The simplified model replicates the real beach at Kelantan coast. This Kelantan coast is called the Irama Beach. We assume the seabed as a uniform and no bathymetry, no irregular bathymetry. The waves are instationary and single sediment fraction is used. So if you want to know more about the morphology or the area around surrounding the Irama Beach, you can just click on this link that I provide you here on YouTube. You can have a look at it first. Okay, and then as usual, I'm going to provide you in the Google Drive the stationary Irama Beach folder. So what you can see in the folder, you will have the, as usual, the grid file, the wave file, the text file, and then you have the depth file, and also you can ignore this one file, and of course you will have the output file once you run the program. Okay, so moving on to our first question. Okay, for this one is a real course. This case has been created by Dr. Shah from UPM. So I'm using his case and I elaborate somewhat and I put additional question in it in order for you to do more exercise on this particular case. Okay, moving on to question number 1. Inspect your depth and grid file. Where are the original coordinates of x and y? How the initial profile looks like? Which depth file to refer to? What is the difference between Irama underscore depth file and Irama 1 underscore depth is an underscore is dot depth file? Okay, for this question, I think you guys already know. If you prepare your grid and bathymetry Delft 3D, you can click on RGF grid file, and then file, you may import the grid file. Go to the folder, the Irama folder, Irama stationary model, and you can call out the irama.grid file. So this is the initial spatial grid. Okay, so the question asks you to locate, to identify where are the original coordinates. Because why? Because you want to make sure that the original x and y should be seaward, because that is the point where the wave will come. It should not be on landward. So we click the view and grid lines and m and indices. So there will be a lot of number here. So just go to the corner. There are 4 corners, so you can just check. The point here. So here, this is the point where it should be the seaward. It should be offshore at this point. So you know that this area should be the sea and this should be the land. Okay, you just want to confirm that. Okay, how the initial profile looks like, which depth file to refer to, what is the difference between irama.depth and irama1.depth file. So if you close this one and then you go for the quick in because you want to know the depth file. File, import the grid file. Okay, first of all, you read your the depth from irama.depth file. So this is the irama.depth file. Okay, irama. If you open another one, file, import grid, and you call the file the depth from irama1.dep file. So what's the difference between these two files? You may notice that I just want you to warn you that this color does not represent the water. Blue doesn't represent the water because you know that the original point is here, meaning that actually the green one showing you the water. If you look at the green one, is minus 13, meaning that this is the depth of the water, the ocean, and coming towards the land. But I think you can change the color. The color doesn't mean anything as long as you understand what's the value, the number means. And you can see what is the difference between these two. The difference here is the base, and this one is the one that they put the two breakwaters. And here you can also check the breakwater view depth color number. Okay, so if you notice here, the darker blue is the place where the breakwater is. So it doesn't have the similar height, beginning with 0.63 uh, above the mean sea level, 1.083, 1.51 meter, and 1.94. And it's similar. This line, this line, this line, this line. It's very same line. Okay. So meaning that from the maybe you go to sampling, you have this uh, Irama Beach uh, initial grid file, and then you wanted to include the breakwater, you change the depth file here. And by changing the depth file, it actually create a two breakwater. But in order for you to make sure that the breakwater is considered as a structure, you need to add the non-erodable layer. Okay, that one we go to the next question. So meaning that is the base, and then you add, you change the depth in order for you to make sure that this is you want to create a tombolo, not you want to create a breakwater, two breakwaters. But after you create a different depth, you want to make sure that that area uh, that you set to be breakwater is non-erodable, because you want it to be assumed as structure. You need to add the another depth file for non-erodable layer. That one we have done previously in the stationary coins, if I'm not mistaken. Okay, so I think you can already answer the question number one. And second one, to check the params.txt file, why position down is now set to -1, and how does it relates to the depth file? Okay, if you go to the params, right click you may notice that the position down is -1. So for those who haven't got any idea what the position down means, you can go to XBeach manual again, and then you can find POS. Okay. You can see here it say the values are positive down by default, meaning that value of 10 is 10 meters depth, but this can be changed using positive down keywords. So if you go back to your quick in, this one, meaning that here is -13, showing that the depth here is show in minus 13 means is 13-meter depth. But because of this modeler wanted the XBeach to read it as it is, so meaning that -13 here will be accepted as the depth. If you put positive down as 1, probably it will read this one as the depth. Okay, so because depth here is -13, the depth of the ocean is -13, and that is the reason why needed to put the post down equal to -1 in order to tell the XBeach that the minus is the depth, not the positive. Okay, why is alpha is set to 0? What is the special grid convention used for grid file? So this one I already mentioned to you. We in the XBeach we have two coordinates, which is number one is called the convention, uh, the Cartesian convention, and then the second one is the nautical convention. So you may refer to the params.txt. Uh, Here it puts theta not equal to 1, meaning here theta nautical convention is used, meaning it reads from here, from the north. The zero start from the north. And if it's Cartesian, it with respect to the east, the x-axis. So, meaning that because of the initial spatial grid is already tilted, so you don't need to use alpha. If you go to the Google map and you read the coordinate as it is, so maybe you extract the data is already 50 degree 50 degree from the x, so you no need to use alpha anymore. But if you do a case where it's uh, 90 degree, okay, perpendicular, and you want to tilt it to the left for about like 20-30 degrees, then you may need to use alpha. Okay, next, number 4, can you estimate the height of the breakwaters, and how do you know if it's erodible or not erodible? Okay, we have mentioned before, if you look at the params, every info will be in the parameters.txt file. If you don't know anything, just go back to the parameter dot. Here the grid parameters show you that the depth file is equal to irama1.depth. So this person or this case does not use irama.depth file. It's irama1.depth file. And then you look here, NE layer equal to irama heart.dep. Heart.dep. So we open another case, new project. Sorry, import depth, irama heart, open. Okay, and then you view maybe the color number. Sorry, color. Okay, if you have something error like this, I think it's better for you to uh, begin it again, close it down, and then you try to read it again. Sometimes it happens. Okay, I read grammar grid again, and then I import back the dep file of iramahart.dep file. Okay, and then I view the grid color number. Okay, supposedly it have to. Okay, now I know what has happened here. Okay, because it already read that one for me. Okay, I close everything first again. Okay, what we wanted to do is like we want to try to read the NE layer file. Read. Import the. Okay. So usually when you read the def file, okay, so something is not right. But what I wanted to show you is that when you go for the NE layer, you will find out that the area where the breakwaters are, the two breakwaters, is being denoted by zeros, while the rest of the point will be denoted by tens, meaning that other area can be eroded by a layer of 10 meters. Only that breakwaters, two breakwaters, is being considered as structure. So we put 0, 0. So next time, if you want to make sure you want to uh, assume a groin or a structure is a 0, you make sure in another file of NE layer, you put 0 at the same place as the structure. So the XBeach will understand that that area is non-erodible layer. Okay, try to read it. I think there's something wrong with my quick in. Okay, I try again, once again. File import with file import. Depth is okay. It's not happening. It's okay. Then you go to the next question. Inspect the params.txt file. Check the flow boundary conditions. What are boundary for front and back used in the simulation? So this one is quite straightforward. You just go to the params. You can see under the flow boundary condition parameters, See, front, back, left, and right. So here at the front, you use the absolute 2D, back wall, meaning without reflection, left Newman boundaries, and also Newman boundaries to minimize also the reflection. All of these are being explained inside the XBeach manual. You can have a look inside there to gain more uh, idea on how this flow boundary uh, wall actually means. And then we go to number 6. Check the params.file. What is the T-stop and what does it mean? What is the grain size and when the morphology will start? Okay, go to params.text. You can see here model time. T-stop is 432,000. Keep in mind that this is in seconds, so you need to convert it to maybe days and hours. So 432,000 you can divide by 60 seconds and 60 minutes and 24 hours. You can approximately 5 days of hydrodynamic time, and the morphology start around half day, I think 12 hours here, and using of morphology more factor of 50. So the morphological time is different from hydrodynamic time. The grain size also here, you can find it inside the parentheses, D50. Okay, check the BC file. What is the wave height, wave direction, and wave period? You can go to the BEC file, irama underscore wave dot text. You go back to the folder, edit with Notepad++. So this is the height and also the frequency. The main angle is 63. Okay, because you have the location of here, maybe it coming from here, 63, the wave coming in. Okay, if you want to know more, you can go to manual. You can see here the definition of typical John Swab definition. If you look at the wave spectrum, okay, here, the wave input, there are two types of wave input. Number one is stationary and also spectral boundary condition. So if you have stationary, usually you can see here the WBC type is the type is either a non-spectral or spatial. Usually when people use John, is spectral, is a wave group. It's not a stationary. You have a wave group coming in. Okay. And then if you want to know more on the spreading, the S is the spreading, directional. Mean angle, wave angle, FP the peak frequency, and HM is the wave spectrum, significant wave height. Okay. By looking at the simulation, how do you identify if the wave being stationary or instationary? Okay, this one I already explained to you. You can look back inside the XBeach manual in order for you to understand more on these specific criteria. Okay, and then you can run the model. It takes about actually quite long. It's not 10 to 15 minutes. And then you can open the quick plot and check the result, any morphological changes around the breakwaters observed. And you can observe and explain on the relationship between wave velocity around the breakwater and the formulation of the tombolo. So if I open here, go open. Okay, so you can have a look at the sedimentation. Oh no, we have a look at the bed level first. Okay, this is the bed level. It's not final yet, but you can. It's not the final time step, so you can compare. This is the initial time step with the final time step. You can observe there's a tombolo. Uh, the formation of tombolo is happening that increase the number of bed level, and then you can also look at the wave height. What is happening when the wave coming in, the wave group coming in? What is happen? So maybe you want to know what is the velocity that's surrounding the breakwaters. This is very important because it's the where the divergence and conversion. So this is the part where I want you to explain more the concept of divergence and conversion along the breakwaters. Okay, and the velocity here will help you in those kind of explanation. So you can see here velocity, and you can maximize zoom in the area. So you can probably see the magnitude. The arrow here show you the magnitude of velocity around surrounding the breakwater, the two breakwaters, the first one and also the second one. So you can relate this magnitude here together with sedimentation as well. This is the sedimentation that is happening around the breakwater. The breakwater is here. The water is coming, taking all the sediments and bringing all back behind the uh, behind the structure and to form tombolos, but you can run. It takes about half an hour to run everything, so I just cut it short because of time limitation, and then you can make your own conclusion. Try to uh, observe change here and there, and you can actually see that is it good to have that kind of breakwater? Is it helps? And maybe in the future, if you want to do some consultation work, you will learn that the length of the breakwater also play important role in the numbers of breakwater and also the thickness of breakwaters. That can be another area to be looked at a little bit into. Okay, I think that's all for number one. We're going to continue for the second part.